Hello, welcome back to my chemistry lessons. I am Adrenaline, the Bazooka Prophet. If you're just watching or seeing my video for the first time, and now this is the part 2 or a continuation of our previous video. Now this one is in a deeper form for students who are preparing for any college exam, O-level exam. You are in SS1, you are in grade 10, you are in grade 11, you are in grade 12, you are preparing for any exams. It is practically impossible to go into any exams without first knowing this foundation: writing electronic configurations of elements. Now, let us see a practical question that says, write the electronic configuration of the following element or ions. Now, please listen to this video keenly as we explain. Now, if you see by my left here, you will understand some basic things here. You see, these are noble gases: helium, neon, argon, krypton, xenon, random. They are considered a template. They are considered as a notation in writing for configuration for element configurations for elements that are larger. Let's take, for example, I can be having something like this. Let's say I'm having, or I was told to write the configuration for, let's say, silicon. Silicon now is not 14. So, which is normally to be 1s2, 2s2, 2p6, right? 3s2, 3p2. Because if you count it up, if you add it up, 2 plus 2 plus 6 is 10, plus 2 plus 2 is what now? 14. Now, if I want to use the shorthand, which I call the condensed form, now take note, if it's 14 now, it means that it's not up to 18. So it will have to fall at this stage here. So it will be neon. So I can come here to say neon, because 2 plus 2 plus 6 is 10. And neon is 10 here. So it will be neon, right? Here become 3s2, 3p2. So both ways can work. But be very careful here. If I'm to make it of this condensed form, take note, 14 is not up to 18, right? So you have to use neon. So any element that is greater than 18 but less than 36, you go for argon. If it's not greater than 36 but less than 54, you go for krypton. So let us do a very huge and practical examples here. So let us see. Now, the real deal. Now, I'm to write the electronic configuration for what now? Ion here. Ion. So for ion here, it is having atomic number of 26. So how do I do it? It will be 1s2, 2s2, 2p6, right, which is 10 already, 3s2, 3p6, right, 3p6, okay, that's 3p6. We'll be having 4s2, then what now? 3d6. Look at it now. So altogether here is 26. So if I want to make use of the shorthand form, what will I do here? Now, I will simply come here to simply say from 6 to 26. So it will be argon, because 26 is less than 30. 26 is less than 36, but it's above what? 18. So I can come here to say argon, right, which is already 18. From here is 18. Can now come to say 4s2, then 3d6. 4s2, 3d6. So this is the correct configuration of ion. For what now? For ion. Now let us continue while I erase the board. Now listen, I erase the board here. All these are examination questions. Now the next one is a very major point here, which is what now? Nickel. Which is nickel. Now in the case of nickel, nickel is 28, and it is plus 2. Now, please take note of this point. Now, if I'm to write the configuration for nickel, I will come here to say, normally, in this ground state, it ought to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2, 3d8 ground state. This is without the charge now, which is 28. Now we should understand that this element here, or this atom here, has a charge, and the charge is positive, and that there will be a loss of electron. There will be a loss of electron. Now, this is where a lot of students have issues. This is where one of the complications starts from. They feel that because this D is the outward atom, that is the outward orbiter, the removal of electrons will come from here. No, electron removal does not come out from this 3D. Rather, it is 4, because 4 energy level is greater than 3. So there will be a removal of electrons from the 4x orbiter. Take note, when the 4x orbiter electrons are removed and there is still more to be removed, you can now move to the D. So in this case here now, what will I do? For this particular species now, right, it will now be 1s2, 2s2, 2p6, 3s2, 3p6. Now take note, we have already removed, because there is already a loss of 2 electrons from the 4x, not 3D. Take note, from the 4x, not 3D. So the 4x has turned to 0 because there was a loss of electrons from here. So here becomes 3D8. You can choose not to put it here. You will still be correct. Is that clear now? Then we now move to another aspect. Please take note of this one is when the nickel was in the ground state. And when we say ground state, we simply mean that state where there was neither a loss or a gain of electron, the ground state. Now we now erase the board to move to the next question. Now this is where my focus is now. Chromium, copper, molybdenum, silver, and gold are one group of transition elements that are exceptions to the rule, meaning they do not follow your normal regular rule. For example, chromium has atomic number of 24. From the rule I gave to you earlier, if I'm to write the configuration of it, which is what was expected ought to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. This was what would have been expected. So in the condensed form now, it will be argon. Remember, I've told you how to do this. Argon, 4s2, 3d4. This was what should be expected, but that is not correct. We don't use feeling here. We don't use what is expected here. We use what should be the actual answer that will give it, or that will give that element its stability. And that exception, which is the actual configuration now, is that there will be a removal of 1 electron from here. You don't throw it away. No, you don't throw it away. You remove that 1 electron from here, then you add it to the next, to this d orbital, making this d orbital to have a total of 5 electrons, making it to be half stable, because the maximum electrons of the d orbital is 10. So half is stable. Now, yep, now becomes the actual one, which is the real one. This is expected. The real one is now 4x1, 3d5. Is that clear now? 4x1, 3d5. And if I'm to Write for the Ohm's rule. Here we just simply mean like this. Remember, the orbital has 5 bosses. 1, 2, 3, 4, 5. So for this 5 here now, singly 1, 2, 3, 4, 5. Now, if they ask you how many unpaired electrons do we have here, the number of unpaired electrons here is 6. 1, 2, 3, 4, 5, 6. We have 6 unpaired electrons for the chromium atom, and as such an element are regarded as a paramagnetic, a situation whereby there is a maximum unpaired electrons. Paramagnetic, we have what they call paramagnet and diamagnet. Paramagnet and diamagnet. Now we'll move to the last one here, which is copper. Now let me erase the board so you can have enough time to do them. Now, move here. The same thing here. Take note of this exception. Now, in the case of copper here is 29. What would have been expected ought to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. So anytime you're having all this exception, always put 1. So in this case here, now so here would have been argon here 4x2 3d9, but the actual form, this is the correct one now, 4x1 3d10. This is what they don't teach you in school. A lot of video out there, but this is the part that you should know, you should understand, and this is where examiners actually bring out questions from, because they know students or some persons do not actually go this deep, and that is where the real marks is. Exception. Molybdenum is also part of the exception too, whereby you'll be having 4x1 as the case may be. Because we have for silver, also have for gold. Now you will help me to do for molybdenum, silver and gold, and you drop your answer for me in the comment section below. When I see it, I will make a review and I will give you the answer directly to you. For now, thank you and God bless you.